Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the types of spectroscopy methods, and in that we have discussed the types of spectroscopy, radiation use and nature of excitation. What type of because we know that spectroscopy is nothing but as a interaction of electromagnetic radiation with matter is known as a spectroscopy. Means the organic molecule, any kind of the organic molecule, when strike the radiation to that molecule or that substance absorb part of it, and that goes into as a excited state or the higher energy state, and that the nature of the radiation, what kind of the radiation absorbed, that will depend upon the structural feature of the organic compound, and therefore spectroscopy provides us the lot of wealth or the information regarding as the structure of the organic compound. And as we know that there are three main basic spectroscopic technique we are going to learn here. Just we are started as a spectroscopy, introduction to spectroscopy, and we are at the point, at the stage where some of the solved example we are going to solve here on the basis of, so that you can get the general information of these basic things regarding that spectroscopy, how to convert one unit into as another one, how to express it. That type of the question may arise, may come in your exam. So for that purpose, let us see what type of or what sort of question will appear in exam. So that we are going to discuss here some of the solved examples. Let us see first solved example is given here, that is a question number first, suppose as a example number 1. So wavelength of radiation is a 2 mu. Wavelength of radiation, wavelength of radiation is 2 micron, right? 2 mu or 2 micron. Express this in terms of, in terms of per centimeter. In terms of per centimeter, wave number and frequency. Wave number and frequency. Wave number and frequency. Wave number and the frequency, that you have to find out. So look at here. Read the question carefully, read the problem carefully. Question number 1, wavelength of radiation is given 2 micron. Express this in terms of per centimeter. What per centimeter? These wave number and the frequency. As we know that wave number, that wavelength is denoted by lambda, right? And wave number which is denoted by mu bar, and frequency are generally represented by mu. These are the what we can call it as symbols represent or denote by the corresponding terms. Let's see here solution, how we can solve it. Solution, let us see here what are the given thing here. So wavelength lambda in terms of per centimeter. Wavelength, first of all, wavelength in terms of per centimeter, that we have to calculate over here. And now for this, wavelength of radiation is 2 mu is given, and therefore, and we know that the conversion 1 micron is nothing but how much centimeter? 10 raised to minus 4 centimeter. As we know that the relation, this one, 1 micron is nothing but as a 10 raised to minus 4 centimeter or 10 raised to minus. So what is the thing you have to calculate in a per centimeter, and that's why you have to convert this unit. You must know that unit in per centimeter. So 1 micron is nothing but as a 10 raised to minus 4 centimeter. Suppose, therefore here is given, wavelength is given 2 micron, therefore 2 micron is nothing but as a 2 into 10 raised to minus 4 centimeter, right? This is the, you just multiply by 2, so you will get as a lambda, as we know that lambda, we are going to calculate as a lambda, right? And therefore that lambda or angstrom, as we know that 2 mu is equal to 2 into 10 raised to minus 4 centimeter. Now wavelength of radiation is 2 mu, and what you have to express this in terms of per centimeter. What you have to calculate? You have to calculate as a wave number. Wave number, what is the wave number? As well as frequency. What is the frequency that you have to calculate, right? We got here wavelength in terms of per centimeter. So this is in a centimeter. Now per centimeter means what? You have to divide this 2 micron into as a per centimeter. So let us first wavelength in terms of wave number. First we are going to calculate wave number. Wave number in terms of wave numbers in terms of wavelength in terms of wave number. First one is a wavelength in terms of wave number. Wavelength in terms of wave number. Let's see over here. Wavelength in terms of wave number. So how do you calculate this? So as we know that the formula for wave number is equal to 1 by lambda, right? And wave number is, as we know that, 1 divided by 2 into 10 raised to minus 4. And when it comes denominator to the above one, what do you get? So 4 means 10 raised to 4 here, 10 raised to 4 divided by 2, or you can write here as a 10,000 divided by 2, 2 into 2, 5. So that is a 500, is nothing but as a 500 per centimeter. That is the wave number we have got, because this is a centimeter, and that when it comes above, it becomes as a per centimeter, that is automatically, and therefore that 5000 per centimeter is a answer in a wave number. Now wavelength in terms of frequency. Now is a wavelength in terms of frequency. Let us see second one. Wavelength in terms of frequency. And as we know that frequency is nothing but as a mu is equal to C upon lambda, right? C upon lambda, where C is a velocity of light and which is 3 into 10 raised to minus 8 centimeter or 10 raised to 10 meter. 3 into 10 raised to minus 8 centimeter, that is a velocity of light. Sorry, here 10 raised to minus 8, 10 raised to minus 10 centimeter per second, which is a velocity of light, or you can call it as a radiation. Light or the radiation. And we know the value of lambda also, right? So mu bar is equal to 3 into 10 raised to minus 10 divided by, which is in a centimeter, right? And now this value, what is this value? Lambda 4 into 10 raised to minus 4, right? And therefore 3 divided by 4, right? 3 divided by 3 into, so let me first say 4, not 4, there is a 2. So 3 divided by 2 into, this one is a not minus, make the correction here please. See here 3 into 10 raised to 10, not the minus sign. I am sorry, let's see here, make the correction. Velocity of light is 3 into 10 raised to 10 centimeter per second. That is the velocity of light or velocity of radiation, which is 3 into 10 raised to 10, 2 into 10 raised to minus 4 when it comes above, and here 3 by 2 it comes 1.5 into, it goes about 10 raised to 6 hertz. That is the value comes over here. So 10 raised to, I think here is a already 10, it goes above, so it comes 10 raised to 14, not the 6, 10 raised to 14, that is the value of this. So you can calculate if you have a, and that is in a hertz. And wavelength, that is frequency is the unit of frequency is a hertz. So in this way you can calculate this one. Now next one, two radiation having, next problem number second we are going to learn over here or see here. Let me clean the board first here, and then we will see the second problem, which are the solved problem we are discussing, we will be discussing here. So let's see second one, two radiation having wavelength, two radiation having wavelength, two radiation having wavelengths 300 angstrom, 3000 angstrom and 20,000 angstrom and 20,000 angstrom. Calculate their energies. Calculate their energies in terms of erg. In terms of arcs which has higher energy, which has higher energy, which has higher energy, which has higher energy, that you have to calculate. Once again, read the problem carefully. Look at here, two radiation having wavelength 3000 angstrom and 20,000 angstrom, calculate their energies in terms of arcs which has higher energy. What are the given thing and what you have to calculate, that first you have to decide. You need to require these things. What are the things are given and what are the things to calculate. It is the important one while solving the problem, while solving such problem. Even though this problem looks as a very simple, but once you know the basic thing about this. Let us see, first one is a solution. What are the things given? Two radiation having wavelength, means let us see, wavelength means lambda 1 is given how much? 3000 angstrom, which is the unit is given angstrom, and lambda 2 also given. What is that? It's near about as a 20,000. Let us consider here wavelength 1 is a 3000 angstrom and wavelength 2 is a 20,000 angstrom, that are the given. Now what you have to calculate? Calculate that energies in terms of arc which has higher energies. Now you have to calculate the energy. You have to calculate the energy E1 as well as and E2. You have to calculate and compare between these two. Which one will be the higher energy? That are the thing. These are the given thing and these are the thing you have to calculate, right? Understood this one? Now let us see over here, calculate the energies of the first radiation. Calculate, first we are going to calculate the energy of the first radiation. And as we know that, what we know? We know that E1 is equal to h nu, where h is a Planck constant. H is a Planck constant which is given 6.62 into 10 raised to minus 27 arcs, right? That is a constant value and which is given. And also we know that mu is equal, this is the equation number 2, but mu is equal to C upon lambda. But mu is equal to C upon lambda, we know that. What we know? Mu is equal to C lambda, where C is equal to velocity of light, which is given 3 into 10 raised to minus 10 centimeter per second, which is given, and therefore you have to calculate over here, put the value or put value of lambda mu in above equation. We get, you substitute here, E1 is equal to H is a 6.62 into 10 raised to minus 27 into C is a 3 into 10 raised to minus 10 divided by lambda, and where you convert this into as a centimeter, 3000 angstrom is equal to angstrom, and as we know that 1 angstrom is nothing but as a 10 raised to minus 8 centimeter, and therefore here you can write 3000 into 10 raised to minus 8 centimeter, which is there. And now if you calculate in your on your computer, so not so sorry, here again remember here the velocity is always in a positive quantity, it is not the negative at all. So remember here, even though I am putting as a negative, that is wrong actually, but here remember 3 into 10 raised to 10 centimeter, which is a correct value of velocity of light in terms of centimeter per second. And now if you do the calculation, what do you get over here? E1 is found to be, so I am trying to solve this here, only this into this minus, so you will get, so if you multiply this, suppose 3 into 2 is a 6, 6 into 18 means 8, 19, so 1.96 into 10 raised to 10 suppose minus, so 17 minus 17 divided by, suppose is a 3000 means 3 into 10 raised to 3 into 10 raised to minus 8, so it remains as a 5, so you will end up with 1.986 into 10 raised to minus 17 divided by 10 raised to 3 into 10 raised to minus 8, it comes above, the value comes here on a calculator, you can calculate at home, and you are going to get the value about 1 into 10 raised to 15 hertz, 1 into 10 raised to 15 hertz. That much amount of the E1 is coming near about 6.62 into 10 raised to minus 12 erg. So if you calculate it, it comes around 6.62 into 10 raised to minus 12 ergs. That is the value comes out if you calculate this. And in the similarly, calculate the energy of the second radiation, that is energy E2 is equal to H nu 2 is equal to nu 2 is the C upon lambda. If you put the value, it comes around, E2 is comes around 0.9. So E2 is comes around 0.92 here. We can solve it properly. Let us see here. E2 is equal to, E1 is over here. Now let us calculate the value of that E2, how much it comes. Now calculate the energy of the second radiation. Here you just make the correction, calculate the energy of the second radiation. As we know that E2 is equal to H nu 2 is nothing but C upon lambda 2. So put the value of this, as we know that C is the velocity of light and it is near about 3 into 10 raised to 10 per centimeter per second, and H is a Planck constant. H is given 6.62 into 10 raised to minus 27 ergs, right? Ergs, that is given, and therefore you substitute the value of this into this equation becomes H into C into 1 upon lambda you can write, or H is near about 6.62 into 10 raised to minus 27, C is given 3 into 10 raised to 10, and lambda is given 1 upon how much lambda second value. Second is a 20,000 into 10 raised to minus 8, which is in a centimeter. if you do the calculation on your calculator, the E2 value comes out to be 0.973 into 10 raised to, how much is there? 10 raised to minus 12 erg, 10 raised to minus 12 ergs, right? Now we got E1 as well as E2. E1 is this much and E2 is a 0.973 into 10 raised to minus 12 ergs. So which one is the higher? What is the what they are asking? What they are here, calculate their energies in terms of erg, which has higher energy. Which has higher energy? Whether the E1, if you observe these energies, if you compare these two energies, E1 as well as E2, what do you see over here? E1 is higher than the E2. It means that E1 radiation has a higher energy than the E2. That is the conclusion we can draw here. I think whatever solved problems are there, two solved problems that we have solved over here. So let us here we have completed as a chapter number first. The name of that chapter is a Introduction to Spectroscopy. That is the name of our chapter. So whatever basic things required regarding as a what we can call it as a Introduction to Spectroscopy, that we have seen. Now let us pay the attention toward what sort of question will appear or may appear in an exam or will appear in an exam. So let's try to find out those important questions and how you can or how will you answer those questions. Let me discuss that point also here. So define the following term. 1 mark question may be always there in an exam. So remember, so what type of the question? Generally here repeating question, year after year these question, the pattern of question is definitely is framed there. It has definite framework. That questions are repeatedly reoccur year after year, because these exams are 2 times in a year. One is annual exam and second one is called as October examination. So students are appearing in these 2 exams. So let's see what type of the important question appear in the exam and how we will answer those questions. So let us see over here. Write the name of radiation used and the nature of excitation in IR and PMR spectroscopy. So generally PMR spectroscopy we haven't studied it, but in the introductory part only 1 mark question, so you have to write short but sweet answer, precise answer, then you will get the 1 mark. The answer of this, the radiation used in IR is the IR radiation and the excitation takes place. There is a vibrational excitation. In IR, vibrational excitation occur along with rotational excitation, because the pure vibrational rotation will not occur. It is accompanied with the rotational excitation. So that is always there in the exam. So remember that one. And for PMR spectroscopy, PMR means what? Proton magnetic resonance. In PMR spectroscopy, what kind of the radiation used? In a PMR spectroscopy, there is a radio waves are used. And what kind of the radiation it produce? They produce the nuclear excitation. So in that way, you have to answer the question of this. Now let us see as another type of the question or the nature of the question. Define the term spectroscopy. At the beginning, I already told you that what is the definition, simplest definition of the spectroscopy. The electromagnetic radiation with matter is known as a spectroscopy. So that is the simplest definition. Next question may appear: which electromagnetic radiation are used for PMR spectroscopy? Give its approximate range in centimeter unit. And we know that in PMR means proton magnetic resonance. What type of the radiation used there? There is a radio waves are used, and unit of that are the centimeter. And next kind of the question, give the relationship between energy and the wavelength. We know that the standard equation according to as Einstein's, E is equal to h nu. E equal to h nu. E stand for energy, H for Planck constant, and mu for the frequency. So this is a standard equation used there. Now numerical problem, and this type of the question always appear in the exam. So what type of the question and how do you answer that? Let's see one example. Express lambda is equal to express lambda or lambda max. Lambda is equal to 950 nanometer in per centimeter. Express lambda is equal to 950 nanometer in per centimeter. What are the given things are there here? While solving that problem, solution given lambda is equal to means wavelength is given how much? 915 per centimeter. We know that what do you know? You know that. So 1 nanometer is equal to how much centimeter? That is a 10 raised to minus 7 centimeter, which is a standard relation. And now 1 nanometer is equal to 10 raised to minus 7. So how much nanometer is given? They are given 915 nanometer, means 950 into 10 raised to minus 7, which is a centimeter is given. So if you put the value here, so 10 raised to 10 means here you can write 9.50 into 10 raised to 2 into 10 raised to minus 7 centimeter, right? And now 9.5, this is a positive sign and this is a negative. So 9.5 into 10 raised to minus 5 centimeter. But you have to calculate this into as a per centimeter. how do you do here? Let's see here. As we know that here lambda is nothing but wavelength in per centimeter, means 1 divided by lambda. So you have to put the value here. So 9.5 into 10 raised to minus 5, whatever answer comes, that is 9.5, approximately 1 you can take over here. So 1 into 10 raised to 5 per centimeter, that is lambda value is approximately this much, not exactly but approximately this one. Or sometime they will ask the 725. If you see the various question paper, different years question paper, you will find only the values they are changing. Sometime you may find 9.50, 725. In some paper you may find 690 per centimeter, whatever value they will give by that, it depends upon that paper set. So wavelength of radiation is 6 mu. Find its frequency in hertz. Wavelength of radiation is 6 mu. Find its frequency in hertz. That type of the question may appear in the exam. So how do you solve that one also? Let's see here. That are the problem we are solving here. Let's see what type of the question may appear in an exam. Wavelength of radiation is 6 mu. Question: wavelength of radiation is 6 mu. 6 mu. Find its frequency in hertz. Find its frequency in hertz. That you have to find out. Now how do you answer this? How do you solve this? Let us see the solution. What are the things are given? Lambda is given 6 mu, right? And now, and what you have to find out? Find out the frequency, means mu you have to find out. We know that the relay, so 6 mu, 1 mu is equal to 10 raised to minus 4 centimeter, means 6 into 10 raised to minus 4 just centimeter, that is a mu, right? And now we know that mu is equal to C upon lambda, and where C also we know that C is equal to 3 into 10 raised to 10 centimeter per second, and therefore put that value C is a 3 into 10 raised to 10 divided by 6 into 10 raised to minus 4, it comes around 1 upon 2, means 0.5 into 10 raised to 10 hertz. That is the value comes out. So in this way, these are the some of the easiest way to calculate this, or express 2.5 mu in per centimeter, or express the lambda max 8750 angstrom unit in terms of nanometer. Define the term amplitude. So that type of the question may appear in the exam. So these are the problem, some of the solved problem we have solved over here. So express 2 point. Let's see another one more question here. So what's it? It is this one. Express 2.5 mu in per centimeter. Express 2.5 mu in per centimeter. That is the simplest one. That we already solved. Express the lambda max 8750 angstrom in nanometer. That also we have solved. So these are the some of the example we have solved. These are the example are important as far as your exam point of view is concerned. I think with this we have completed as a chapter number 4 here, introduction to spectroscopy. Remaining we will see in the next lecture. Thank you. Have a nice day.